Welcome back to another live stream. I found something pretty interesting on Twitter. How does a conservative become a liberal? How does a liberal become a libertarian? How does a libertarian become a conservative or a liberal again? It's pretty interesting stuff. Stay tuned.
You are now relearning economics.
Welcome back to another live stream. Make sure you hit that notification bell so you can be with me till the end of time. Hit that like button, leave comments underneath the video. I'll try to answer them all. Also, if you're in the live chat, say hello. We'll bring that up on the screen in a little bit. I wanted to do a stream today because I had found something on Twitter that was quite fascinating to me, and I'll bring it up here in a second. Let's bring it up. It is causal loop diagram. Okay. So in this causal loop diagram, you have liberals, you have conservatives, and you have libertarians. Now, first, I have to say, this was a satirical causal loop diagram I found on Twitter. Somebody had made a post about it. So I'm not saying that what we're going to do is I'm going to model this today. I want to show people how you take a causal loop diagram and convert it into a mathematical model. But I have to declare, I don't think I believe in the structure of this model, but you can model any structure you want. Now, what I'm showing on the screen is a causal loop diagram, commonly referred to as a CLD. It's not the assumptions. The assumptions are the parameters which I'll show when we model this out. It's showing the structure. Now, you'll notice there, again, are liberals, conservatives, and libertarians, and then there are flows. Okay, so a liberal has two flows going into it, one flow being fired and one flow for medical bills. And then it has two flows going out of it. So one starting a business and one being because they were mugged. Now, obviously, you're seeing the satirical pattern going on. The other two, conservatives and libertarians, both have a flow, two flows going in and two flows going out. So for conservatives, the flows going in is having kids and being mugged. For libertarian, the flows going in are being arrested and then starting a business. And of course, they have corresponding flows that go out. Now, you can model this when you look at a causal loop diagram. So, in consultation, when I build models, we start from diagrams like that. Now, obviously, they're not going to be satirical diagrams, but you can get an idea of how the system structure is going to be. Now, I can draw that diagram out for a prospective client, or that client could have already drawn out that causal loop diagram and says, Here, Ty, model this for me. So, if I bring up that again, the first thing I would have to do is address what are the stocks and what are the flows. Now, in this diagram, it's quite easy. The vernacular used tells you which is the stock and which is the flow. And the causal diagram, that the wiring kind of shows what are the stocks and what are the flows. And obviously, the stocks are a group of people that are liberals, a group of people that are conservative, and a group of people that are libertarians. And the flows going in between those stocks would be fired, mugged, medical bills, having kids, starting a business, and being arrested. So right away, I know what my stocks and flows are. As a modeler, it's my job to figure out what the parameters are going to be. What are the assumptions of the model? We can build out that model quite simply, and that's what we're going to do today. First, I'm going to say hello. If there's anybody in the chat, let's bring it up. Frank is here. How you doing, Frank? Good to see you. If you're in the chat, make sure you say hello. And as I'm building this model, if you got questions, bring them up. Obviously, I know the model itself is satirical, but the goal here today is to kind of show this. Now, but the original poster might have been serious to a degree. This maybe they were a libertarian. I'm thinking, this is how the world works. And we can kind of put this into practice in an actual model. So I'll bring up Ravel, and we'll just kind of start from there. Can we do entire screen? Let's do the entire screen. We'll share. bring that up. We will make it large. And we'll keep we'll bring the chat down. Make sure if you're in the chat, say hello. So I know I'm not alone. We'll bring down, let's take down some of these graphics. They're pretty intrusive to say. And so we had 3 stocks, we said. So we can grab 3 integrals. Grab them 1, 2, 3. And these are going to represent our 3 stocks. So a stock basically is going to have an integral attached. So the inflows will go up here. Your initial condition will go right there. We can name these. So let's start naming these. And first we can untoggle them. So now we can move these around if we desire. We can name them. So the first one we had was, let's say, conservative. And let's use abbreviations. So we'll call conservatives C C subscript N. Okay. We'll put the initial value in as a parameter. We know these are going to be persons. So it's a unit of persons. We'll make sure we're dimensionally consistent. And we'll give a long name, conservative. So when we hold our mouse over, we can see it's conservative and it's in units of persons. Go and we'll do the next one. Let's untoggle this. Now you can move it around again. We'll do our second stock. This will be, well, we'll say these are for libertarians. We'll go L subscript N, so libertarian. Units of persons again. Libertarian. So now we got our libertarians. Now we need our liberals. And we'll toggle this again. And for this one, we'll say maybe L subscript liberal L. Sure. And we'll give this a unit as person as well. It's very important that you assign units to your model. So when you're mathematically doing it, you have a flow, which will be, person per time year, et cetera, et cetera. And this is liberal. And so we have our 3 stocks. Now, if we bring back the diagram, we've got our 3 stocks, but we need a bunch of flows. Okay, so I'm going to start creating those flows. So the first one is fired. Just type it in. Let's try this again. Fired. And let's actually just say F for fired. And we don't have to do the units for this because it'll be developed in the equations. And we'll just go fired. When you hold your mouse over it, you know what it is. So fired. Getting mugged is another one. So we'll just use M for mugged. We'll put the long description. And some other ones. Medical bills. Okay, let's do medical bills. We'll call medical bills M subscript B. Medical bills. Say another one we need is having kids. We'll call this H subscript K. And they called that has kids. Find another one in this. Arrested. Dun, dun, dun. Well, we'll just say A. And they define it as arrested, which is another flow. And I think we have one more. Starting a business. Started a business. We'll just call this SB. S subscript B. I define that as started business. Okay, so now we got all our flows. We got to figure out what flows go into what and define these equations here. So these will be ordinary differential equations. Let's take a look. We'll do conservatives first. So let's back out, give us a little bit of room. We'll move these off to the side and we'll define what are the inflows and what are the outflows. First, we'll grab a minus operator. So we'll wire in the inflows into the plus input and the outflows into the minus input. Bring up our chart again. What is going into conservatives? Well, they have kids and they get mugged. So we can have kids and they get mugged. Okay, looking good. We can wire those in. And then what are the outflows for conservatives? Well, getting arrested and medical bills. So arrested and medical bills. Wire that together. Wire that into the input of the integral. And let's pick an initial condition. And let's say we have a population of around 100 people. Then we can kind of look at this as a percent. So we will say C subscript N 0. And because this is in latex, we'll put curly brackets around that. This will be a parameter constant, so we'll change it to a parameter. We'll say it's 33.3. So we'll get up to 99.9, close enough. It's in units of persons. Initial conservative. Wire that in. And we'll make this so this is not adjustable. You can see a little black dot there. We won't have any sliding effect to that. And now we can see we've got our initial condition of 33.3. We've got our equation here. If we go into our equations, you can see we've built an ordinary differential equation. So d C subscript N over dt equals H subscript K plus M minus M subscript B plus A. We created our first ordinary differential equation, and our initial condition is 33.3. We got to do that for the rest of these stocks. So let's do the libertarians first. Got the libertarians. Let's go back to our flows. What are the inflows and what are the outflows? We'll do the inflows first. The inflows are starting a business and getting arrested. I don't know. This might be a little derogatory to libertarians. So, like I said, this was a satirical causal loop diagram, but hey, we can take anything and model it dynamically, structurally anyways. So getting arrested was one of them. We can take a copy of that. And the other one, what was the other one again? Let's bring that back up. Getting arrested and starting a business. There's starting a business. So like before, wire inflows into the plus import on the minus operator. And then we need our outflows from libertarians, and that's having kids and getting fired. Okay, well, there's our getting fired one. And then we'll make a copy of having kids. And as you can see, this is going to be stock flow consistent. If you look at the causal loop diagram, if a libertarian has kids, well, those kids have to, kind of transfer something. We're conserving these flows. So it's going where it's stock flow consistent. So we got that. We can wire that in and we can pick an initial condition. I want to start this model in equilibrium. So we'll go L subscript N we need our curly brackets, 0. And this will be the initial condition for libertarians. Um, units of persons. And we're going to say 33.3. So we're going to try to start this model in equilibrium and then shock it. And let's take the slider out. Now we've created our second ordinary differential equation. You can track your equations on the equations tab in Ravel. So here you can see d L subscript n over dt equals S subscript b plus a minus f plus h subscript k. Let's do our final ordinary differential equations. This is for liberals. Maybe just move this over a little bit here. And what are inflows for liberals? Well, getting fired and medical bills are inflows. We'll take this down. So getting fired, that's F, copy, and medical bills. We'll take a copy as our other one. Let's just take a quick look at what the outflows are for liberals, and that is getting mugged and starting a business. So we can find the start the business, which is S subscript B, and getting mugged, which is M. Copy. And we can grab another minus operator, wire them up just like we did before. So our inputs going into the plus input and our outputs going into the minus input of the minus operator. Wire into the top input of the integral. And we'll pick an initial condition for L subscript L. So we will go L subscript curly brackets L0 curly brackets. We'll set this as a parameter. So it's not going to change. There's nothing endogenous about it. We're setting the parameter ourselves. 33.3. It's in units of persons. We don't need a slider. And we can wire that into the bottom port of our integral block. And we have our three ordinary differential equations. But nothing's going to happen if we run this model because we have no dynamics for all the flows, and we're going to have to do that next. But we can check the equations, and you can see we have our three system state systems. So now we have libertarian, so d L subscript n over dt equals S subscript b plus a minus f plus h subscript k. So we've got our three ordinary equations, and we got to define some sort of time unit in this model. So we'll go up to our simulation settings. We use a fourth order solver, so we're not going to worry about any of that. We'll have maybe a runtime of 20 years. I'm going to pick a time unit of years. Makes sense. Okay. So we got a time unit of years, and I'm going to create a parameter called tau, and this is my first assumption in the model. So we'll go slash tau. And this is going to be the transfer rate, the half life of flows over time. And we're going to say it's 4. And basically, I'm saying, people change, their political affiliation over a 4-year period. Makes sense with election cycles. What's a time constant? What unit would it be? It would be in its time unit. So we'd pick a time unit, which in our model is year. We're not going to change that. So now we have our first assumption that people are going to be transferring to different political affiliations over a 4-year period. Now, this is just an assumption that I'm making. It could be different in real life if we're going to try to quantify this model. But for illustrations and qualitative dynamics, this will be good enough. Now, one of the things I've already modeled this before, as I discovered, is there's a preference. So if we bring back this model, or this causal loop diagram, you'll notice that there is one bad option. So we'll take a libertarian, for example. There are two outflows. One is good, having kids, that's a good thing, and one is bad. That's getting fired. And you'll notice it's the same for each one, which makes this causal loop diagram kind of ingenious in a lot of ways. It was almost like this person was like, somebody might try to model this. If you look at liberals, one of its outflows is bad, being mugged, but one of its outflows is good, right? So we're getting into the idea of preference. Okay. And so maybe we need some parameters like gamma for good and beta for bad to start defining what percentage of people, let's say liberals, get mugged or start a business. Now, I'll decide it's going to be a 90-10 split. So, 90% of the people will start a business and 10% will get mugged. In the real world, maybe it's only 1%, but for illustrations, that'll be good enough for now. So what I can create, let's for instance say mugged. Let's define what mugged is. So we grab mugged. We go back to our causal loop diagram. What influences getting mugged? Well, you got to be a liberal to get mugged. Okay, that makes sense. So let's grab the liberal stock. We need that. We're going to need a copy of our time constant. Definitely going to need that. Okay, so far, so good. What else do we need? Well, getting mugged is going to be a bad thing. So let's call the percentage of people getting mugged, let's call it B. So beta. So we'll go beta and we'll subscript it, and it's for mugged. So we'll call that beta subscript M. This is going to be a constant parameter in the model. It's going to be 10%. So we'll go 0.1. It's dimensionless, and we'll just call this the mugged rate. This will actually not. We'll make this a flow, and I'm going to show you why momentarily. So now we can actually kind of create an equation here. And so we'll take liberals, divide times, so multiply by the mugged rate, grab a divide by operator, and divide it by our time constant of 4 years, and then wire that into our mugged. And now we've defined at which rate people will get mugged in this model. Well, the other outflow for liberals, so we'll take another copy here. What was it? Let's bring up the... So getting mugged is one outflow and starting a business is the other one. And this was a good option. So let's say starting a business. We'll grab that. Copy. And we're going to say this is gamma. Gamma subscript start a business. And so we'll curly bracket this. Start subscript business curly bracket. And we'll call this a start biz rate. And I forgot to add our backslash. This should make that work. So now we got gamma, and it's going to be the same kind of equation. We'll need the tau again. So we'll take liberals and multiply it with the gamma variable, and then we'll divide it with tau, which is our time constant of 4 years. And then that gives us our rates of starting. Now, did I do that wrong? Did I grab MB? Is that medical bills? So liberal. So I grabbed the wrong one. Let's remove that out of there. We'll use it for later. Starting a business is SB. So now we've defined the two outflows from liberals. And so I'm going to continue doing that. And now I'm going to look at the outflows from libertarians. So we'll go back to our causal loop diagrams. What comes out of libertarians? Outflows: fired and have kids. Fired is our bad option. So let's do fired first. We'll grab F, copy. We'll grab our libertarian stock this time. Going to be the same process again. We'll create beta subscript F. This is to get fired. Fired rate, we'll say. Need a copy of tau. Same process as before. Need a multiply block and a divide by block. So the percentage of people that are going to get fired and the time constant to which that happens. We've defined how people get fired. Keep in mind, we're going to have to define all these, which will be parameters in a second, and I'll show you how to do that. We can go and do the next one, and I've noticed I had this up. So what I've done here is I've added this flow here. So libertarians times beta subscript F, which is the fire rate, divided by the time constant, gives you the amount of people that will be fired each year. We'll do the other outflow for libertarians, which is a good outflow. Let's have kids. So let's grab H subscript K. We'll copy it. We'll grab another copy of the libertarian stock, and we'll create gamma subscript curly brackets have kids. Close that. I'm just this is all just kind of latex I'm putting in there to format the text. This is kids rate. Just call it that. It works for now. And we can put that over here, grab our gamma variable, grab a tau variable, grab the operators we need. It's a little bit repetitive here. Wire it all together. And now we've defined having kids, which is, libertarians times the kid rate, having kids rate, divided by the time constant, which is 4 years, which will define having kids. So now we've done the two outflows of the libertarians, and we've defined 4 of the flows. We've still got 2 more flows to go, and we'll define them from conservatives because they're directly affected by conservatives, and that's their outflows: medical bills and being arrested. We'll do the being arrested first. It's the more negative one. Preference-wise, people would rather just pay medical bills than get arrested, I would hope. We'll grab our stock. We'll drop this out of the way. We'll grab our conservative stock. We'll zoom in here. And we'll create beta. We'll call this beta subscript A. And this will be our arrest rate. Arrest rate. We'll grab a copy of tau again. Grab our mathematical operators, which is a multiply block and a division block. So conservatives times the arrest rate, divide it by the time constant of 4 years, gives us our arrest rate. Notice how I use dimension, like I'm defining what the dimension is, persons, right? So up here it's a stock of persons, our time unit is year. Now that gives us our arrest rate, which is persons per year, defining what a flow is. We got one more flow to do, and it's one of the good ones, or a good one. So for conservative, is it paying medical bills? Maybe that's not good, but this is like preferentially good. And it's going to be very important what I'm talking about preference here because we're going to perform an experiment. There's that medical bill we tried to define early on. We need a copy of our conservative stock, and we have something good, so we're calling good gamma. So gamma subscript curly brackets medical bills, so M subscript B, close with curly bracket, medical bill rate, we'll call this. And again, we need our tau, which is our time constant. Make a copy. Do this one more time. Grab our multiply and our divide by operation blocks. So conservatives times your medical bill rate, divide it by our time constant of 4 years, gives us the percent of flow for the medical bills. So we've defined all of our, we don't need this one, flows now, and this will, of course, update in the equations. So now we've got all our flow equations, we've got all our ordinary differential equations, but we got to create some shock variables. So as you can see, we haven't defined what these are. So I'm going to do that now, and we'll do our first one. It'll be the libertarian. Let's do our libertarian shock, and we'll call it libertarian shock. And we'll make this a flow. And we're going to make this between 0 and 1 with kind of a 1% change. You'll kind of see how that works out in a bit. It doesn't need to have a dimension. We're going to make two constants, unnamed constants. One will represent 10% for the bad outcomes. And then for the good outcomes, it would be 0.9. And we want to do next, we want to maybe put that there. We'll grab a minus operator and a plus operator. And I'm just making it so we can do shocks for those beta and gamma. So the libertarian shocks, we can grab those right here, copy, and then copy. So the good one is here, and the bad one is here. And just double check that I'm doing this correctly. Well, I can see I'm spelling libertarian incorrectly. Let's just change that. So everything's correct there. And when I shock the system, if I do a positive shock, it's going to increase the good and decrease the bad. So this went down to 9%, 0.9. This went up to 0.91%. If I do a negative, it'll increase the bad and decrease the good. And this is the shocks we'll implement. So we've now defined beta subscript F, which is the fire rate, and gamma subscript H subscript K, which is the having kids rate. And we've got to do that for each one. So let's do the liberal ones next. So we need the beta variable and the gamma variable for liberals. So that's starting a biz is the good one. Getting mugged is a bad one. We can just copy these, I believe. It'll work out. Just copy that. It's going to be the same situation. This time we'll say this is a liberal shock. Liberal shock. And between 0 and 1 will be fine. And our step size will be 0.01. So that each time I press the cursor key, it goes up by 0.01 or down by 0.01, with its maximum range being 1 and its minimum range being 0. This is a parameter. We'll make it blue. Same deal as before. Grab a minus operator, a plus operator. And we've now defined both gamma and beta for the liberal shocks. Same as this above when we can shock this when we're running the model. The last one is the conservative shock. So conservative shock. We'll set this up in the same manner. Between 1 and 0, step size of 0.01. Grab a copy of 0.1. Grab a copy of 0.9. Grab a minus and plus operator. Wire them. You can do this whatever order you want. Each time I've done it a little bit different. Ultimately, you just got to make sure you wire it correctly. And so for the conservatives, you've got your beta, which is your bad preference, which is a rest, and then your gamma, which is a better option. Just let's double check that we are doing this correctly. So conservatives, yeah, outflow gets rested, outflow medical bills, correct. Good option and the bad option. And we've literally defined a whole model here. You can look at our equations. So we have parameters that we set. We have these parameters, which are just, basically defined by the shocks, then our flow equations, and then our ordinary differential equations. Well, that's all cool. What happens when we play with this model? Well, first thing we got to do is maybe create a graph to see what happens. I don't know, make it about that big. We'll grab copy of libertarians and liberals and conservatives. And we'll plot the stocks. And you can just wire it into your input. Try to keep this as organized as possible. Maybe name this. So, I don't know. Political affiliation. The time, the x-axis is the year, and labels are persons. And just because we defined it as person as a unit, we'll put S to represent its multiple units. We'll make a legend. Can we make our pen styles look good? Sure. We'll change that black to maybe a blue. And we'll make the lines thicker. Okay. So we got a plot going here. And we can probably put that plot on the publication tab. So now it's on its own little separate tab. Go out there, grab our shocks. We're going to put those on the publication tab too. So now we can kind of shock the system live. Just put them right there. And, we can plot the flows as well. And I would suggest, because, some flows are large, some are small, we plot the good ones together and the bad ones together in separate plots. So maybe graph like that, save that size. So we'll just copy it, copy selection, and then should be able to paste it. There we go. So if we take the good flows, so starting a business is a good flow. Having kids is considered a good preference. Um, and then medical bills is better than being arrested, we've decided. So that was a good one. Wire those together. Maybe just, name this chart good flows. Sure. And this will be years. And then it's person per year. Pen style. Yeah, same thing. I like blue more than black. How's that? Make them thicker lines. Sure. Deal. So we got our good flows, and then we have our bad flows. So bad flows are, well, obviously fired's not a great thing. Arrested, not so great. And what was our other one? Getting mugged. Definitely not a good thing. So we can wire those in together. Just kind of keep it tidy here. I'll put them together. We'll name this one bad flows. Sure. Bad flows. X-axis is years. And it's person per year for the flows. And let's make sure we put our legend. I don't think I put it in the last plot, and I'll go back to that. Again, I like blue. Make them thicker. Okay, let's just make sure we got our legend for this one. Perfect. So we can maybe move them down here. And as you can see, the system's in equilibrium, which is what we want it. We do that. And then we can put these into the publication tab as well. Oh, maybe have bad flows and good flows on either side. Something like that. Have our shocks. And we've created a model. So let's see how this model performs. And let's say we want to introduce a negative libertarian shock. And that means libertarians, if we look back at our causal loop diagram, a negative shock is they get fired. And you would say, oh, well, then that's going to mean there's going to be a lot more liberals. Well, let's see what the emergent behavior of that shock is. I've slowed down the runtime here, and I'll introduce the shock at time 5 right now. And we have our dynamics, and we see something interesting happening in this model. I set the time limit to run to about 20, which kind of gets us to our equilibrium point, and the model stops. And we see that the liberal population does go up. But we also see that, in fact, it feeds back into the libertarian stock as well. So the only thing that shrinks is the conservative stock when more, and I'll bring up the chart here. So when more libertarians get fired, there are more liberals. But the emergent thing here is this stock here. It's not really emergent. This is a small model, but if there's more liberals, then they start more businesses and it feeds back into libertarians, right? Yeah, the conservatives are kind of lost on all of this. They're kind of got swamped out. But you'll notice that eventually the conservative column starts declining. Okay. Because if you look at it, the more liberals are, the more muggings there is. So if there's more muggings, there's more conservatives. So it starts slowing that decline down. Same with having kids. The shock was either fired, have more kids, or pardon me, that would be over here. So there's the shock of having getting fired more, and then the counter shock. So you're having less kids. But notice because eventually the liberals start businesses, the stock of libertarians start rising again, and you have more kids. If you're having more kids, it slows the decline of the conservative stock down. This is what nonlinear modeling is. Nothing is just straight A to B. What if I did the opposite, right? So, and I've had the graph up. So, what I was describing here is that libertarians start having more kids and conservatives or liberals start getting mugged more, and it slows that decline of conservatives dropping off, becoming libertarians and liberals, and thus it slows the increase of libertarians and liberals. What if I do another shock where it's a positive shock for libertarians? So I'll return that to 0, restart the simulation, run it again. So now libertarians have more kids. And now conservatives go way up, and both libertarians and liberals go down. So different emergent property, but you're like, well, shouldn't that be equal? Well, no, not in a nonlinear system. So what's happening here? When libertarians have kids, they become conservatives. Um, but more conservatives there are, a portion of them will get arrested, so they'll become libertarians again. But a portion of them will more likely pay medical bills. They'll become liberals. Of course, liberals start businesses and they become libertarians again. Some of them will get mugged and become conservatives again. You have all these non-linear dynamics equaling what happens here. So libertarians, even though they're having more kids, you say, well, that should decline really fast. Well, a portion of the conservatives that were libertarians get arrested and become libertarians again. You can see the nonlinear dynamics to this. But what's a real interesting part of this simple model, and remember, this was just a satirical model, is the idea of preference. Now, remember, I said there was a preference of, a 90% to 10% split, right? Obviously, people, are going to want to start a business versus, getting mugged, right? They're going to do all the things, whatever. We didn't model what those things are, but we're assuming that, they're going to be more successful at starting businesses versus getting mugged. But what if we had set all of those to 50-50? So now there's no preference. Either or could happen. So I'll just set that. I'm wondering if it'll change my other two, or do I have to? Yeah, it did change them. Okay, that's good. We'll change all of them to 50s. And those two should change as well. So now we've made it a 50-50 on all these things. So we'll do that original shock before. And that original shock was a shock of a bunch of libertarians getting fired. And now we've got a 50-50 preference, so either or. And we can run the dynamics of the model. Remove that. Again, run it. Now you can see just a strange thing. Oh, that's because we started with a shock. Let's start in equilibrium. Start in equilibrium at time 5 will introduce the negative libertarian shock, so more people are getting fired. We're seeing dynamics, but because no preference exists, the libertarian stock actually just stays in equilibrium. And it is becomes a zero-sum game between the other two system states, which are conservatives and liberals. So preference in dynamic models, whatever assumption you make. In our case, we made an assumption that they were constants, but maybe you had a function where these are variable and they change over time. Preferences are huge, and our preferences are percentages in this model, but it changes the dynamic completely. But we know in the real world, we have preferences over other, some things we prefer more than others, and those will materialize over time. And obviously, that introduces some non linearity into the system. And let's check out what's going on in the chat here. Sorry, I've been missing out on you guys, and I guess we'll go through. Oh, there's a bunch of people. Well, hello everybody. How you doing? Steve Keen in the house. I don't know if he's still here. Run. Thomas is in the house. Michael D'Souza Cruz. Michael D'Souza Cruz. I have not seen you in a long time. Let's just pull this down. Let's stop sharing this. Let's get this big ugly mug up. Where you been, Michael? I haven't seen you in a while. Hope you are well. Doesn't erectile dysfunction lead to conservatism and liberalism? So in this model, that was the satirical part is you could have added in place of getting fired erectile dysfunction, right? It was a satirical causal loop diagram. But what I was trying to show you is that is the start of a dynamic model. So either your stakeholder could give you that causal loop diagram, or you could draw one for your stakeholder, maybe somebody you're consulting for, and say, here, this is what I'm seeing in your system. Do you agree with it? Because if I pull that up, um, it's pretty anybody can understand this, right? It's just, some words with, causal arrows driving the flows between them. Anybody can understand that. And maybe my stakeholder says, well, you know what? Libertarians don't get fired and go to liberals. They get fired and they go to conservatives, and they might redraw the line. As a modeler, then it's my job to decide, is that a flow? Is that a stock? What are the assumptions of the model, which were all the blue variables in the model? But that's how you go about it. So we could have had erectile dysfunction for sure in the model. What do we got? Let's see what we got here. Let's bring this screen back over here. One man in it here today. There we go. Now I can look at you guys and press buttons at the same time. Kind of just go through any chats that I missed here, guys. I hope everybody's well. Germany's here. How you guys doing? I did a whole hour building that model. I thought I'd go a lot faster. Steve, I apologize for my slow modeling. I wonder if you could have done that faster. And aren't you supposed to be teaching a class today, Steve? Alex, conservative here. Alex, what did you think of the model? Realistic or unrealistic? Keep in mind, I did not make that causal loop diagram. I just modeled it. What else we got here? So by this logic, a rational and all-knowing representative agent of liberals would be extremely tough on crime, and a conservative would be encouraging muggings to get more converts. Again, the causal loop diagram was definitely satirical. And that wasn't my concern when I modeled this. My concern was just modeling it to see how it would turn out, and it was kind of interesting, to say the least. Medical bills again. I decided when I was modeling it, I noticed there was a good preference and a bad preference. So the alternative to medical bills was getting arrested. So if imagine people, we know that people aren't rational, but they are somewhat rational, and they have, in this model, it's very binary. You have two choices. As a conservative, you can get arrested or you can pay medical bills. Hopefully, I'm hoping conservatives would pay, okay, I'll pay my medical bills and not get arrested. So it is the better of the two options, right? um it's that's the way the causal loop diagram was built. If I had built the diagram, I would have picked something like better. Conservatives go skiing or they go get arrested, but this was the diagram I found on the internet and modeled it. What is a medical bill anyways? It's a bill for medical services. So the assumption in the causal loop diagram, and I'll bring it back up again, is that if you're paying more medical bills, conservatives become liberal. If a conservative is getting arrested more, they become libertarian. Now, the structure of this model, it's satirical. I don't agree with it as a real world actual model. Again, what I was doing there was just showing you can model any causal loop diagram or structure, then add your own assumptions. My added assumptions was that there was a better option and a worse option, and that if one of them had more preference than the other, you would get some nonlinear dynamics. If they were both 50-50, you would lose some of those nonlinear dynamics, and a shock to one of the stocks would become an either or sum, or what would you call this, a zero sum game for the other two stocks if the preferences were equal. But since we know in the real world preferences aren't equal, and this would really tickle the libertarian brain because they love preferences. We know that people would prefer one thing over the other. You start getting a little more nonlinear behavior in the model. What else we got in the chat? I didn't want to do a long stream today. We do have, compared to our brothers and sisters in the South, we do have a better healthcare system. That's for sure. I can't believe it. Steve, you're doing a good job at trolling here. Here we go. Here. Cults and brainwashing, and indeed. I'm assuming you're referring to the Liberty. Steve, do you want to come on the chat? You can come right on and yap if you want to yap. If you're not doing anything. Michael D'Souza Cruz. I would love to see a system dynamics models of cults and brainwashing. In fact, if that was a two system state model, so again, if I brought up this chart and let's say it's cults and brainwashing, and they were two of the system states, and let's say it was liberals and conservative, we just canceled that out and we drew lines between the two. It'd probably be a zero-sum game. It wouldn't be that interesting. So, Michael, if you could come up with cults, brainwashing, and something else, once you add that third system state, you get some nonlinear dynamics and emergent properties like you've never seen before. Um, so, who else? You missed it. I missed you, Ty. I missed you too. Even though I'm sure I managed to irritate you with our last live stream, I'm pretty sure. What can I say? I learned from the master. Okay, hold on, Steve. Actually, Steve, if you've got your last email for the live stream invite on Friday, that link will bring you on. If you don't, I can email you right now. What else did I miss here in the chat? Steve will come on in a second. Frank, heading to Toronto for a Jays game with the kids in June. Any recommendations on other things to do while in town? I live in Vancouver, so I have no idea. Go to the CN Tower? um, June. What series is it? Maybe I'll get tickets. We'll meet. Steve, how do I join? Do you have the link from Friday's stream? Because that'll work and get you in if you still have that. If not, I can attempt to email you. And I'm going to save my file and close it right now. So we'll call this model 3. Sure. Save. It's going to make my computer do a little bit better. Maybe I have to email Steve, guys. Did you find the email, Steve? It would have been the email from the Friday stream. There we go. I found him. Here he is. Let's bring him on. Steve.
Gotcha. Okay. Hang on a second. Hello there. Hang on. I've got it on the wrong screen. Not hearing you. Hang on a second. What's going on there?
Can you hear me?
I can hear you now. Yeah.
So what did you think about that causal loop diagram? Now, keep in mind, I didn't make it. I found it online a week ago.
I thought it was quite cute. I think you and I saw it at the same time, and I thought that is quite a cute example of how you can build models using stocks and flows. Very and getting feedback effects, which most people aren't, never really aware of what a feedback effect is. So very nice, I thought. I'm still trying to see if I'm looking at the right screen here, though. Hang on a second. Here we are. This is the one I wanted. Okay, over here. Yeah, so that's great. Nice little demo of how to use Ravel in a positive and fun illustration. So very cute.
Because those were conservations of flows into each stock, I could have used a godly table and done it that way.
True, you could. That's a good point.
But the problem is I would only be using one asset class, and with let's say the pandemic model, you can have your asset as the population stock, your liabilities as the system states of where you are in infection, and then when you're recovered, you become equity, and you can use each asset class. Where in this model, I would have had to just been stuck in one asset class, so I chose not to.
Possibility. It's
do that.
Yeah, I mean, if you have got 100% of population there, and you one or the other, so that does make a case for using the godly table side, and the one increasing, one decreases another. Be fun to see, actually. That'd be a nice little demo.
Actually, we'll do that now. So what I could, and what I'll explain, I'll do, and then I'll show is, so I had 33.3 for each stock as an initial condition. So that means I could have created a population stock as an asset, which would have been 99.9. If you add that asset to the 3 liabilities, I would have balanced my row to 0. So I will bring up my model again here. Stand by.
Okay.
Where did I save it? I saved it right here. I'm gonna have to do some fancy articulation with my model or my monitors here. Yeah, I'll put you guys over here on this monitor. I will bring up my model again. Stop sharing screen. Oh, I'm still sharing.
Yeah. No, you're still just saying, here we go. That's got it. Yep.
There we go. That was actually pretty weird. So, Steve, I actually shut down that model file, but Restream, when I opened the model file back up, it found it. It like still had that connection.
Oh, good.
Interesting
Okay.
stuff.
Yeah.
Let's drop the chat for now. See you later, guys. I can't see you anymore. So I had my three stocks. Now I can grab a godly table. And I'm gonna have to name them differently, aren't I?
Yeah.
Yeah.
Or,
So
yeah.
so
Or
let's
you could whack that in a separate model and cut and paste. That's possibly another way to go about it. I'm not sure how well that'd work, but if you go back, just shut the godly table down, and if you just try to grab all the definitions you've got of flows in there. So don't take the integral blocks, but just move all the integral blocks out of the way, rubber band it, and move them all out of the. Yeah, that's right. Move them out of the way.
these are all my ODEs right here.
Yeah. We're going to create the ODUs using godly table instead, or give it a try, and then zoom out and grab all the flow definitions you've got there. Of course, they include some of the stocks. That's probably going to stuff up the idea I've got here. But if you grab all the flows there, yeah, that's
You
the
know,
6.
you know what I can do though
Yeah, what?
is I can just delete all this
Oh,
stuff.
yeah, okay, and then recreate them in the
Yeah.
godly table and take them out of there.
So I'll get a new. Yeah, exactly. I will.
Yeah,
Once I create them in the godly table, I can then just reattach them.
yeah. So
Okay,
there's create
and then
yours. Yeah. Oh, okay. Yeah, that works too.
yeah.
Yeah.
And in fact, I won't even need. I'll keep these for reference temporarily.
Yeah.
Oh,
Oh,
something
you need the
happened.
initial values. You got to bring those back. You need the initial. Oh, no, they're going to be.
Oh, they're
You
going to be
don't. You're right. The initial values become in the initial parameters of the godly table. Okay.
Ravel does not like what I did there.
Yeah, I mean, I saw one of the people saying it's a much better program than he saw back in 2016. Yeah, of course, there's been 9 years of part-time work going into developing it, not full-time, unfortunately.
Let's
But
just
yeah,
save as, and we'll call this one model 4, and we will close that out. And hopefully that gets rid of that little bug. I've noticed that before. Nope, that has destroyed the file.
oh, what a
Nope,
drag.
no,
Sorry
no,
about
it's
that.
no. I
Yeah,
think I have something where it's I
the
have
element might still be there.
right here.
Okay, because you still got the graph span
There
down.
we
Fair
go.
enough.
Okay.
Okay.
So grab our
Yep.
godly table. We had C subscript conservative. I can C subscript N. Oh no.
No, you want to
No.
make the population
So we'll call that N
for people.
population.
Yeah.
So then we'll have 3 liabilities.
Yep.
So we have C subscript N for conservatives, L subscript L for liberals, and then I had for libertarians, I had L subscript N.
Yep.
And then, you know what? I'll just call this E because we're using it to balance the equation.
Yeah.
We know that I had 99.
99, yeah, 99, but make it 99, 33, 33, 33.
33.
Just a thought. Yeah, make it.
That's
Oh, no, 99,
What are you talking? It should just balance this way, though.
All right. Okay. No,
Right.
33.3. Yeah. Fair enough. All right.
Yeah.
Yeah.
33.3. And actually, this way is a lot faster than defining on the canvas the way I
That's
did
right.
it.
Yeah. That's one of the when you can use a conservation law or um, a materials flow balance, then the Godly table's far faster than doing it using a set of differential equation
It
blocks.
seems to believe there is an extremely small gap.
Well, it is to 14 decimal places, so yeah.
Whatever.
Allow that for your computers.
So
Okay.
anybody that's watching, this is
Yeah.
essentially zero.
Yeah.
Not to be worried about. So I'm gonna minimize this a little bit and work from two windows here, and I'm gonna look at my flows.
Yeah.
Where
Well, you
did
can
I?
actually define the flows now. Yeah.
Exactly.
Um, yeah.
So I can make this smaller, and if I do my first one, which I've deleted what these are, so I will bring up my causal loop. So H case is having kids and getting mugged.
Well, HK takes you from libertarian to conservative. So you have a minus HK in libertarian and a plus HK in conservative.
Oh yeah, okay. I'm looking at the wrong
Yeah.
directions.
Think
So
of now in terms of if you've got to flow from one stock to another. So this is
arrested is an outflow of conservative, and
an inflow
medical
and
bills is an outflow. So this is the
yeah,
conservative one. Okay. So I can start working on this.
yeah.
The first one I'm going to do conservatives first. So I'll address all those having kids.
Well, in fact, you put your 6 flows, mugged, getting,
Yeah,
having
I
kids.
am. I
Yeah,
am.
yeah, cool. I
Yeah.
can't see it though. You got the
Oh,
form
okay.
still in the way.
Okay.
That's better. Yeah, okay. Yeah.
So I'll do the what we called the preferentially better um options, which is medical bills,
Yeah,
believe it or
yeah.
not, versus getting arrested.
Yeah, okay,
Um
yeah. Medical, yeah, okay.
Start. Remember, it's a relative
Yeah, yeah, I
to.
take that.
Oh, start.
I take that one on board. That's okay.
Yeah.
Yep.
So those are three goods. Arrest it. What a terrible option. Arrest it.
Mm,
Getting mugged is not so good.
mm. Be careful about that in Toronto.
And
Uh,
and get yeah, who was that? Frank, be careful when you go to Toronto. You might
There's
get
part, yeah,
mugged.
what's it called? The Yowley Street, I think, to the right-hand side. I made the mistake of walking down there one day, and I very quickly turned tail. Not a standard piece of behavior by me, but I saw the people, I thought, "I don't belong here." Okay, having kids, so it's going to
So having kids increases the
yeah, it's conservatives,
HK,
yeah.
HK, and that comes from the libertarians. So if I go minus, oh yeah, I
H
can do. Hold on, I can utilize this feature,
yeah.
which you can't see on screen because I'm stuck in dual screen.
Oh, okay.
Hell, we'll just type it.
Yeah.
H subscript K.
There we
Of
go.
course,
Yeah.
balances our row at the end. Medical bills.
Convert you from which to which? The medical bills from conservative to liberal.
Okay,
Okay, so it's minus conservative, yeah.
M subscript B, and that goes into liberals. M subscript B.
Yep.
Starting a business is
Minus
liberal to libertarian.
Yep.
So liberal to libertarian. So this is minus S subscript B. S subscript B.
Yep.
And then our next one for getting arrested is conservative to libertarian.
Okay.
So that
Yeah,
yeah.
you can start there. Increases libertarians.
A and at minuses from
Yeah. Yep.
Conservatives. The next one is getting mugged, which subtracts from liberals, adds to conservatives.
Yep.
So M
And minus M. Yeah.
and minus M. And then getting fired is subtracts from libertarians and adds to liberals.
Yep.
That's pretty sad. I've remembered this model now. So libertarians, it subtracts, so that's F, and adds. And so now I've defined all the stocks and flows this way for anybody that's still watching, and I balanced it out. I know there's 99.9% people, and because I want to start this model in equilibrium, that's why I went 33.3 for each one.
Yep.
And this is a very, 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 very small rounding error that I do not care about. So I can go in there and I want to grab all those variables, stock variables, right here. And now I have all those stock variables. I don't need N and I don't need E. And everything that I've done here is now done in the godly table. I don't need it anymore.
Yep.
Cut that. And now I can take copies of this and try to remember where they all were. That's okay. I can do this, Steve.
I know you can, mate.
We'll just go back up here and look at the ones that are subtracted from this MB and A.
Put it in editor mode and show it on screen.
Oh, good idea. Let's editor mode
And then stretch, yeah. There you go.
Okay. So we know M is anything that is a minus is defined by that stock. So MB and A are defined by the conservative stock. So if I take that conservative stock and there it is. Yeah. Okay. So grab it, wire it, copy. Okay. And then for liberals, starting businesses and being mugged right there. So that is our liberals. Need a copy. And then by issue of elimination, we know these are these. And so we've redefined our thing, and I'm wondering if I can be clever here and put that on the publication tab and go to our preferences and allow us to see the values.
And also make it plus and minus rather than debit and credit too. But anyway.
Okay.
Just to make it, yeah. We've got to make that a much more flexible option in future. Okay, that's better.
There we go. And oh, you know what? I didn't save after I made my publication tab. Huh?
I'll save it model 5 or model G for godly.
I'm gonna need another copy of my stocks to rebuild.
Okay.
That. Now I have my jumbled mess. And we'll maybe put that there. You know what?
Yeah.
The godly tables really slow down the publication tab.
Do they? Okay.
Yeah. Just just kind of noticing versus the last version.
Yeah.
It's a little glitchy on dragging things around, but it doesn't
Yeah.
matter. I've got to it. And now we can zoom in. And I seem to have
Okay.
highlighted.
And then,
I have highlighted SB for some reason in the publication tab. There we go.
yeah.
And run the model. It should be not in equilibrium because
Something's not working.
Oh, you know what?
Oh, yeah.
Gotta define. So anybody that's watching, if you want to do a mass unit change in a godly table, you can set currency, which is actually just setting your units. We define that as person. And so now all of the stocks in there will be updated with person. If I were to add another stock after, I would have to do that process again or individually add that unit. And I'll just do it. Oh, what?
Oh no. Okay. This is one of the hassles that it maybe
What
is
is
being defined dual in person to unit -1.
They're all there, all of them. You know what? I think it's a bug.
Probably a bug. Yeah. I mean, the thing is, this is throwing you in the deep end, suggesting doing this in the middle of a
That's
unpracticed
okay.
presentation anyway. But it shows the fact that you can do it two different ways in Ravel, and one I think the godly table, which is the unique feature that Ravel adds, is better than the flowchart system in terms of understanding the logic, because you can look at the table and you can see effectively the plus and minuses on the rows are the inflows and outflows on the causal loop diagram, and it's just you can see, as you show, you're showing the flows through there, all very good. So yeah, interesting kind of stuff, mate.
Good
Nice.
times. Good
Yeah, there
times.
you go. Aren't we ever nerds? Aren't we ever
We'll
nerds?
we'll save that.
Okay. Come back.
Close
Well,
that.
I'm gonna hit the sack over here. It's 11:30, heading towards midnight. So I'll leave you
What?
to it now. Yeah.
What?
Yeah.
Hold on.
Yeah.
Let me bring. Let me shut down my screen before you go.
And so what's happening on
Close.
YouTube crowd? Anybody still watching us, or are we on our own?
Oh no, I'm sure now that you're here, you've made the place
Let's hope so.
famous.
Okay. Yep.
Anyways, guys, that's all I was gonna really do anyways on today's stream. Just showing everybody, if you have or see a causal loop diagram online, something like that, and they happen on LinkedIn all the time. Everybody's got their little diagrams. And if they're feedback diagrams, well, pull out Ravel and model it. And it's very simple. You can make your assumptions very simple. So I used a universal time constant of 4 there, representing the election cycles. And I decided there was a better preference for one and a less preferable option for the other flows. And you can essentially test anybody's little diagram to see, because they may have a description showing and saying what's happening in their diagram, but when you go to model, it's something else completely different happens. That's what you
the outcomes
discover.
are more complicated than people realize. Yeah.
Yeah.
Very cool, mate. Okay. Well, I'll say
Yeah.
good night and see you
Okay,
on
Steve.
Friday.
See you on
mate.
Friday.
Bye-bye.
Bye,
Bye.
Steve. There you have it, guys. Steve Keen. Leaving. Let's can I remove this source? Now it's just me and you guys. That's all I was going to show today. Is that system dynamic modeling doesn't have to be common. Now that was a really small causal loop diagram. And obviously, if you're building a national economy, you'd have about 30,000 feedback loops, not 12 or whatever were there. But that's how you start a model. All my models start really small. You test a module on its own, see if it behaves. So you're looking for a reference mode. That model I wouldn't test ever because it's a satirical model. But if you had a small scale model of unemployment, you would just test that module itself against real data. So you would, find some in sample data, use it as a reference mode, calibrate your model, hope that you could forecast with it in the future. And then you would add each sequential part onto the model afterwards. Um, but yeah, let's see what Alex has to say here. Plate had a good feedback loop. Masculine republic leads to feminine democracy, leads to tyranny. I assume it loops back somehow. Yep. What's going on here? Who else? Michael. I have 3 kids, soon to be 4. I'm a liberal, pro-democracy. Now, what did the causal loop diagram says? Oh, you become a conservative. So, here's the thing. Let's postulate, Michael. So you're a liberal. Now, if I made this diagram, obviously liberals have kids. So what happens when they have enough kids is I would actually create a temporary loop, Michael. So each kid that assuming you stayed in the hospital and you stayed up all night, and this may apply more to your wife than you, they become conservative because they are tired and exhausted. Giving birth is I'm as a man, I don't quite understand it, but it must be very freaking intense. So you draw a line and you become conservative. But as soon as you have that kid, Michael, your medical bills go up and you become liberal again. So you have what I call temporal conservatism. And you temporarily become a conservative after having a kid as a liberal, but quickly swing back into becoming a liberal. But then, as you're taking your kid for your first walk, you get mugged as the father. You become a conservative. You get very angry because you were with your kid, Michael, and you beat the living holy hell out of that guy, and you get arrested, and you become a libertarian. As a libertarian, you're like, well, I've got 2 choices. I got fired from my job because I'm beating up guys in my neighborhood, so I can't get fired anyways. So I might as well have a 5th kid. You become a conservative, but you instantly become a liberal again because you got to pay more medical bills. And the story goes on and on. I hope that answered your question, Michael. Again, the model causal loop diagram is highly fraudulent and satirical. I wouldn't put much thought into it other than you can just take those kinds of systems and test them out if you want. If somebody especially on LinkedIn, all the stupid little diagrams I see on that platform about people, professionals saying, "Here's the flow chart to success," and if it's a good flow chart, the loop will feed back into itself because no system is open. All systems are closed. That's the way the world works. There's no such thing as A, B, C, done, problem. Right? It never. It just feeds back into itself. Um, so anyways, you can actually tell, and then if I had the time, I'd go on LinkedIn and do it to everybody's chart and just fucking troll the hell out of them. Um, but anyways, it's about all I got for today. I've got to actually go do some real work. I just decided to do an extra stream today. I'll be back on Friday with Mike Radzicki and Steve Keen. I haven't picked a topic yet. If you guys have any ideas for a topic, put them in the comments underneath the video and I'll consider them. If you're on my Patreon, put a comment there and I will consider it. But it was good to see Michael. It's good to see Alex. Old Heretic, I haven't seen you in a few weeks, few months maybe. I haven't really done many streams lately, so it's good to see you too. Who else did we have here? Henrik. Might have saw you in the last stream. Um, Thomas. Thomas. Good to see you here, buddy. Who else? That wasn't a big stream today. It was, not a large one. Now, I've noticed when I looked at our last stream was our best one yet. We had like 50 people on my little channel. So that was a good one. And I noticed like it peaks around the 60-minute mark. And then if it's a good stream and Steve and I are like saying outrageous things, it just holds steady. But if we just start pulling at straws, people start dropping away. What else? Just making sure I didn't miss anybody in the chat who said hello. Frank was here. Frank, I never got a reply on your Blue Jays deal. Whatever. Any new chats before I go? Story of my lifetime. Yeah, I told you. Hey, if you need a consultant to build you not an economic model, but a system dynamic model about having kids, Michael, I'm only $250 American an hour. I'd be more than happy to do it. But you might end up mugging people to pay that bill. So maybe don't do that. That might add a whole. Is there any snow there? No, in Vancouver. So basically, in Vancouver, it rains. So we have all the mountains around us. So our skill hills, they get snow all the time. Most of BC gets snow, but right here on the coast, which is like a valley, it's mostly rain all winter. A couple times a year, it'll snow, but it very rarely gets to zero here. And then it's been a little warmer here this year, so a lot of rain, lots of flooding, all that sort of stuff. So no snow yet. Hopefully, like one snowfall. I like the snow. My dog likes the snow, but um, would you like? I would like you to do a model with corporations, a branch of government, a corporation as a branch of government. And then you follow up. I would like you to do a model with corporations as a branch of government. How would be a branch of government? Like accounting wise, you can make that happen, but behavioral wise, governments in aggregate. So state obviously governments behave differently than federal governments in aggregate. So all the down in the states, Congress people and whatnot, collectively make it like a large agent as the government. Corporations, collectively, they kind of make behavioral equations, right? And those equations differ from one another. Like, so, what happens if I pull out my national model? I could show that, but you can easily unify a balance sheet into one national balance sheet if you want it to. It's just you lose some nuance there, but I could do it. Um, but the question is, why would I do it, Michael? What is your plot here? What is the game you are playing, Michael? Does this have something to do with MMT? uh, I could, but I need a better description of what you want me to do. Um, and then maybe I'd do it. You did. You missed all the action. You missed you can watch the recording of this. It looks like I missed all the action. Guess I'll never find out how dogmatic social path becomes an apathetic bystander. Well, actually, you can just watch the video. So I can show you. I had found this graphic on Twitter, a satirical graph of how libertarians become conservatives, liberals become libertarian, and vice versa, right? And all it was is just a causal loop diagram. Well, I actually built a model just to see how it behaved when I shocked each part of the model. I don't actually believe in that causal loop diagram, so you didn't miss anything on the reasons why some psychopaths become other psychopaths. You just missed a modeling exercise of how you can see those diagrams, and you see them on LinkedIn all the time, and build your own math model out of them to see. Usually they come with the stupid little diagram, and then somebody has a description saying, see, this is how the world works, this happens, and then presto, everything's solved, right? But if you actually take that and model it mathematically, you get these completely different results based on their own fucking diagram. So, anyways, that's all you missed. Um, nothing, nothing of urgency at all. It might look like reality if you do. Well, again, building corporations and the government, regardless of how you integrate the balance sheets, you still need behavioral assumptions and hundreds of equations. So you'll have to be a little more descriptive than that. Um, if you can, maybe I'll give it a shot, right? Um, but so corporations are profit driven. Ideally, social democratic countries, not the United States, but places like Canada and Norwegian countries, their motive is social issues, so social inequality, and by no means are they efficient at addressing that, even if they simply understand that there's no financial constraints. There's always real constraints, and how a governments handle that. They're often inefficient, but so are corporations. They're inefficient too, but their motives are completely different, right? So a social democratic government like Northern Europe countries and Canada and whatnot, there's a social motivation for them. Whereas the corporate, bottom line, it's corporate profits. They're profit driven. So you have to address those behaviors, and they're going to react to different system states in the system, right? So at different times, the economy might be in a different state, right? Government will react differently than business, right? So how you meld those two on the behavioral side is far different, because then you're dealing with things like production functions, right? Why do firms produce things, right? Why do governments produce things if they own any of the means of production, right? And completely different sets of behavioral equations there. And how do I know that? Is because I've done the statistical work, right? Right. So often I'll do correlations, whether it's just basic linear correlations, right? Or linear regression, or VAR models, right? I'll test different things to see, how institutions behave over time versus other institutions. Governments and corporations behave drastically differently. Even if you look at the two government institutions like the Federal Reserve and the Federal Treasury, both of them have different motives, right? They might meet every Friday. Well, they used to. I don't know if it's happening so much with the Trump government, but back in the day when there was at least some reasonable people, like during the Great Financial Crisis, you had Geithner, who was the New York Fed, and then what was Henry Paulson was the Treasury at the time. They would have weekly meetings, right? And discuss, the next round of treasury auctions, because obviously the Fed needs to give the reserves to the primary dealers, so the primary dealers can participate in the auctions. Um, but even looking at those two institutions, right, they both behave differently. They have both different behavioral patterns, and you have to model that. And when you make them interact, then you get nonlinear behavior out of it all. So it's a very complicated thing. You can't just make a T chart and say, well, here's my model, right? Because that's not the way, dynamic systems work. It's part of it. They should be stock flow consistent, right? And you should understand, why things come into existence and go out of existence, right? That's definitely important. One of the great things that MMT does, right, and has taught the world, despite Austrians hating it so much. What else we got going on here? Alex Jenkerson. Government generally doesn't produce any material wealth, but lots of corporations also don't. Most of it is just consuming materials into a service of some kind. Only difference is who pays. Well, service is something to somebody, right? So, material wealth, yeah, sure, whatever. That's a whole nother story. What I was talking about is the motives of a corporations is different than the motives of a government. It's completely different. You have to model it mathematically, completely different. What else we got? You would have to incorporate rank-seeking behavior, endless loop. Yep. Anyways, Michael, always good to see you. Oh, one more from Michael. That's right. Reserve ad before reserve drain. It's true. True. You can't taketh away if you have not giveth first. I got no problem. Like I've got no problem with any of that. I wish Austrians would listen to MMTers, right? Because then they could get some of their praxology right finally at some point. You know, imagine if there was like an MMT unity between Austrians, and it was like post-Austrianism. Oh, that would be something to see. Who would lead that? Right? Who would lead that crew? Oh, that'd be something to see. That'd be one hell of. I thought. Okay, well, Bob's actually the only Austrian I like. He's actually, you know what? He's willing to engage. I give Bob credit where credit is due for Bob Murphy. So there's that. Government do not want. Get me my computer mouse. Governments do not what? Get me my computer mouse. I don't know what that means. Anyways, I'm gonna go, guys. It's fun. See you on Friday. Bye-bye.
You are now relearning economics.